Hey, this quick little video is going to talk about convergence for a geometric series for the Chapter 10 Calculus Practice Test. And for question 2, which is what we're looking at, we're supposed to find all the values of x for which this series, the series of 3x plus 1 to the n power, where does this converge? The first thing I like to do is just to take a look at what the series looks like expanded. And that's going to give me a real sense about what kind of series am I looking at. Now, it just so happens that this series looks like a geometric series because to get from one term to the next term, say from here to here, all we needed to do was multiply by 3x plus 1. And then we keep continuing the pattern. To get from the second term to the third term, we're going to multiply by 3x plus 1. Which means I'm looking at a geometric series. The first term is 1, and the ratio is 3x plus 1. Because it's a geometric series, it plays with a different set of rules than the normal Maclaurin or Taylor series would. For convergence, the absolute value of the ratio needs to be less than 1. For our series, that means that the absolute value of 3x plus 1 needs to be less than 1. If I compare that to x minus center is less than the radius, I can see that I've got to divide both sides by 3. So we'll divide both sides by 3, and that'll give me x plus 1/3 is less than 1/3. Or x minus negative 1/3 is less than 1/3. Compare now to x minus center is less than the radius, and I can see that the center is going to be negative 1/3, and the radius is going to be 1/3. Now that I know that the center is negative 1/3 and the radius is 1/3, I can use the standard interval notation and say that x must be between center minus radius and center plus radius. This is always the form that we're going to be using for our intervals of convergence, which simplifies to x must be between negative 2/3 and 0 for convergence. Now remember, because this was a geometric series, we don't have to test any of the endpoints here, and we're done with this problem. We can move on. So we'll see you on the next one.